Welcome to EDU World Space.
In this question, the situation is about an airliner which is flying horizontally, okay, and then after a while it drops a rocket, okay, drops a rocket over here, and while the airliner is moving at 850 kilometers per hour, and then it travels at a straight line, okay, and then the rocket, okay, it falls, it drops the rocket, and then it undergoes projectile motion, and at some time it will uh, it it turns on its engine, and then it starts to move up, okay, so let's move up like that while the airliner continue to move straight, and we want to find at what time that the rocket should uh, turn on the engine, so that when the rocket come up at the same height as the airliner, there's a distance of 1000 km between the two objects, okay. So when we solve this problem, we want to draw a diagram that shows the flight paths, okay. So this is what I have drawn over here. It shows the flight path, okay, and so this is the time that the rocket needs to switch on the rocket engine, sorry. And then we also need to draw the xt graph for the motions and the yt graph for the motion of both objects as well, okay. So this is the flight path, okay, of the rocket and the airliner, okay. So at the same time we can start to draw the xt graph. So the the airliner is moving at constant velocity, so it looks like this, okay. And then the rocket initially is also moving at constant velocity because before it turns on the engine, okay. And then after, when it turns on the engine, it starts to accelerate, okay. So it starts to move up, okay, starts to move up like that, okay. Okay, then the yt graph of the airliner and rocket, okay. I'm going to set the y equals to 0 line as the airliner, as the line for the airliner, okay. So the airliner will go horizontally, okay. The y position does not change, it maintains at the same height. And then for the rocket, initially it drops, okay. It follows a parabola, and then at the lowest point it turns on the engine, okay, and then it starts to go up, okay. Okay, so this is the time that the airliner, no, the rocket would switch on the engine, okay, so that when the rocket reaches the same height as the airliner, they are 1000 meter apart, okay. Oh yeah, 1000 meter, 1 km, sorry, okay. Okay, so to solve this problem, okay, we recognize that the motion of rocket has two stages, okay. So the first stage is under free fall, okay. So x1 equals to e naught x times t, and then y1 is minus half gt squared, and we also note that vy is equal to minus gt, okay. And then in stage 2, Okay, the engine switch on. The engine is switched on. So the acceleration of the rocket is 3g, the magnitude. So ax is 3g cosine 30 degrees, and ay is equal to 3g sine 30 degrees. Okay, and so the position of the rocket in stage 2, okay, is x equals to x1 plus e naught x t minus big T square plus half ax t minus big T square. Okay, and then y equals to y1 plus v naught y t minus big T, there's no square here, plus half ay t minus big T square. Okay, and for the vertical motion, okay, at time t, okay, y is equal to 0, okay, which is the airliner's height. So we set 0 equals to minus half gt square minus gt small t minus big T plus half 3g sine 30 degrees t minus big T square. Okay, so from this equation, okay, we let u equals to small t minus big T. Okay, so this is what we get. So we have 304 9.8 u square minus 9.8 t times u minus 4.9 t square equals to 0. Okay, so we have a quadratic equation in u. Okay, so u is equal to 9.8 t plus minus 9.8 t square plus 4 minus 4 is c, so the c has a negative sign, so it becomes a plus. So 3/4 9.8 times 4.9 t square. Okay, and this whole thing square roots. Okay, divided by 1.5 times 9.8. Okay, this is 2a. And so we found that u is equal to 1.72 big T or negative 0.387 big T, and this is not applicable. So we have T minus big T equals to 1.72 T, which means that T is equal to 2.72 big T. Okay, then we have so the rocket and the plane, okay, their distance will be 1,000 meters when they are at the same height. Okay, so we'll write down the position of the rocket. So we have v naught x times big T plus v naught x times 1.72 T plus half 3g cosine 30 degrees times 1.72 T square and minus v naught x T is equal to 1,000. Okay, so this is x plane. Okay, this part here is the x of the rocket. Okay, yeah, so it follows this equation over here. This is the equation for x for the position of the rocket. Okay, so okay, so just substitute all the things inside. V naught x times 2.72 t plus half 9.8 root 3 over 2 1.72 square t square minus V naught x 2.72 t is equal to 1000, and you can see that these two terms cancel out. Okay, so we have t square is equal to 2 times 1000, okay, divided by 3 times 9.8 times root 3 over 2 times 1.72 square. Okay, and then after that, you take the square root. Okay, and this is 5.15 seconds. Okay, so this is the answer for this question, and that's all.